Ever wonder how we're teaching machines to learn like us? Well, get this.
The 2024 Nobel Prize in Physics just went to the masterminds behind it.
John J. Hopfield and Geoffrey E. Hinton for their game-changing work on artificial neural networks.
It's not every day physics acknowledges something as seemingly biological as learning, is it?
This really highlights how impactful artificial neural networks
Or ANNs, as we call them.
truly are.
They're blurring the lines between how we understand brains and how we build machines.
It's wild to think about, and we're diving deep into all of it today.
Guided by the Nobel Committee's own breakdown.
Scientific background to the Nobel Prize in Physics 2024.
They don't just give out the awards.
They explain why this stuff matters, like on a huge scale.
Absolutely.
And to appreciate just how far we've come, we need to rewind a bit.
Back to the 1940s.
Imagine computers as these giant calculators.
Wizards at crunching numbers, but utterly clueless about things we humans do effortlessly.
Like recognizing a face or understanding speech.
Yeah, asking a computer to decipher a handwritten note back then would have been like a
Asking it to compose a symphony.
perfect analogy.
See, early attempts at AI were like trying to write down every single rule for every single scenario.
Talk about tedious. Did they really think they could program a computer to understand the entire world that way?
That was the initial approach.
But it quickly became evident that this rule-based programming was incredibly inefficient, especially for complex tasks.
Okay, so if meticulously programming every single rule wasn't the answer,
Where do they turn to?
scientists started looking for inspiration in a most unexpected
Or perhaps expected.
place: the human brain.
Instead of rigid rules, our brains learn through a complex web of interconnected neurons.
And this very concept sparked the birth of artificial neural networks.
So instead of programming every little detail.
We're now talking about creating systems that learn and adapt kind of like our brains do.
Exactly.
It's a fundamental shift from rigid instructions to systems that learn from experience.
Recognize patterns and make decisions based on the data they're fed.
So we've got computers trained to mimic the human brain.
Talk about a sci-fi concept come to life.
And that's where our Nobel Laureates
Hopfield and Hinton?
step onto the scene. Right?
Absolutely. They were pioneers in bringing this brain-inspired computing to reality.
John Hopfield, a physicist, published a groundbreaking paper back in 1982.
Introducing his model of associative memory network.
Okay, associative memory.
You've piqued my curiosity.
Does that work how I imagine it does?
Like when a certain scent triggers a vivid childhood memory.
Precisely.
Imagine you catch a glimpse of a blurry picture of a friend.
Your brain effortlessly fills in the gaps based on what it already knows about your friend's appearance.
Hopfield's network, in a simplified way, achieved something similar.
So it's not just storing data like a file on a computer.
It's making connections and associations.
Much closer to how our memories actually work.
Exactly.
And here's where Hopfield's background in physics gets really interesting.
He drew inspiration from the behavior of magnetic systems.
Where elements influence each other's spin, creating patterns and stability.
His network mirrored this behavior, blurring the lines between the physical and computational world even further.
Wow, that's incredible.
It's like he found a way to translate the laws of physics into the language of learning.
But we have two pioneers to cover here.
What about Geoffrey Hinton?
What was his groundbreaking contribution?
Hinton enters our story with a focus on probability and learning.
His work in the 1980s on the Boltzmann machine was a complete game changer.
Think of it this way.
Instead of trying to memorize every single picture of a cat ever taken,
The Boltzmann machine learns the essential features that define a cat,
this allows it to recognize any cat.
regardless of its breed pose or even the lighting in the picture,
So it's not just about memorizing data points.
but rather understanding the underlying patterns.
The very essence of what makes something a cat, right?
Exactly.
And this was a crucial step towards what we now call deep learning.
While the Boltzmann machine itself had limitations in practical applications.
It paved the way for more complex, multi-layered networks, the backbone of today's most sophisticated AI.
And these multi-layered networks.
Those are the powerhouses behind the AI we see everywhere today, right?
Self-driving cars that navigate through traffic.
To those eerily accurate song recommendations that seem to read our minds.
You got it?
But Hinton's contributions don't stop there.
In the early 2000s, he made another groundbreaking discovery.
Restricted Boltzmann machines and a technique called contrastive divergence.
Okay, This is where it gets even more fascinating, right?
You're about to tell us how Hinton cracked the code on deep learning,
Exactly.
training those powerful multi-layered networks we talked about.
The deep networks was a massive challenge.
Think of it like trying to teach a dog a complex trick by showing it a million different pictures at once.
It's just overwhelming, right?
Hinton's work on restricted Boltzmann machines and contrastive divergence
Provided a more structured, efficient way to train these networks. And that's what ultimately led to the explosion of deep learning applications we're seeing today.
So instead of bombarding the dog with information all at once,
We're breaking down the learning process into smaller, more digestible steps.
precisely.
And that breakthrough was revolutionary.
Suddenly, AI could tackle problems that were practically impossible before.
Remember those banks using AI to read handwritten checks in the 1990s?
That seemed like magic back then.
And it was all thanks to these advancements.
And then in 2012, AI helped scientists discover the elusive Higgs boson particle.
By sifting through mountains of data.
It's amazing to see how far we've come in such a short time.
I mean, I even used an AI to help me write a poem the other day.
Not sure if I should be impressed or a little freaked out about that.
But here's what I find most fascinating.
Yeah.
This isn't just about cooler gadgets or smarter algorithms.
This Nobel Prize celebrates a fundamental shift in how we understand learning itself.
Both in our brains and now in machines.
That's a brilliant observation.
If you connect this to the bigger picture,
ANNs are not just a technological marvel.
they're a new lens through which we can view and understand the world around us.
And the Nobel Committee really emphasizes this.
By highlighting the impact of ANNs on fields far beyond computer science.
You're right.
It's like giving a biologist a powerful new microscope.
Or an astronomer a cutting-edge telescope.
But with ANNs, the possibilities seem limitless.
They have the potential to revolutionize just about any field you can think of.
Absolutely.
We're talking about revolutionizing medicine.
Imagine AI helping doctors diagnose diseases earlier and personalize treatments with incredible precision.
Or picture ANNs analyzing massive climate data to predict weather patterns.
And help us tackle the challenges of climate change.
And in materials science, ANNs are leading the way in discovering entirely new materials.
With mind-boggling properties like superconductivity or enhanced energy storage.
Things that could change the world as we know it.
It's truly mind-blowing.
But as we celebrate the incredible potential of ANNs,
It's also crucial to remember the ethical implications.
we're talking about extremely powerful tools.
Right.
And that raises some crucial questions for all of us.
As we build these increasingly intelligent machines, how do we ensure they're used responsibly?
And for the betterment of humanity.
How do we prevent biases from creeping into algorithms that make decisions about healthcare
Loan applications.
or even criminal justice?
These are not just hypothetical questions.
These are the challenges we face right now, today.
It's like we're living in a science fiction novel that's still being written.
And we as a society have a say in how the story unfolds.
So what does this all mean for you, our listener?
I think it means staying curious, informed, and engaged.
Because the future of AI isn't something that's just going to happen to us.
It's something we're all actively shaping.
Every choice we make today will determine the direction AI takes.
And how it influences our future.
Well said.
We're at a pivotal point in history.
We'll leave you with one final thought to ponder.
Something that wasn't explicitly addressed by the Nobel Committee.
What's something their work undeniably hints at?
If artificial neural networks
Machines.
can learn and adapt, as we've discussed,
Could they someday achieve something akin to consciousness?
and if so, what would that mean for humanity?
It's a question that sparks endless possibilities and challenges us to consider the future we're creating.
With every line of code,